We did not get to the word problem. I know all of you were just waiting for word problems. I know. But again, it's one of those things where in order for this to be relevant to real life, we have to every once in a while see a word problem where we go, oh yeah, that makes sense, you know. And we really already saw that with the mayor's salary restored and the realization that no, they didn't restore it. They thought they did, but they didn't restore it all the way. So we were where? Yep, right here. So how does this whole thing work with word problems and formulas and stuff that's going on in real life? Well, you can't just suddenly say switch the x and the y, because in word problems, they usually mean something, you know? C equals 2 pi r. That's the formula for circumference that you had back in geometry. We can't suddenly say that every radius is exactly the same as the circumference and every circumference is the same as the radius. That doesn't make any sense. So we can't switch those variables. So when we're finding that inverse of real world problems, you can't switch them. What you can do is solve for the one that's not solved for. And that's what we need to do. So we simply solve for the, fancy name, independent variable, the input. So the first thing we have to do is talk about these formulas and say, okay, what is this solved for right now? And what would I do if I needed to solve it for this instead? So here's a couple of real nice little formulas here. The first one is the original. Area equals pi r squared, and that's for a circle. Now, if you answer this question, you'll know which variable this is solved for. The what of a circle? The area of a circle. That's what it's solved for right now. If we needed to use this formula to find the radius, it's not built for that. So what we do is we say, okay, well then let's get r by itself. Then it'll say r equals, and it'll say the radius equals. So if we start with a equals pi r squared, the first thing we'd want to do is divide both sides by pi to get that over to the other side, because right now it's being multiplied. So the inverse operation would be to divide it. And then we have to think, well, how do we get rid of squaring something, which we did yesterday? That's square root. And normally, when we write down a square root symbol, we have to put a plus or minus in front of it. But this is a formula for a radius of a circle. It can only be positive. You can't have a negative radius for a circle. So that would be our formula. And that's the one we see up here. So how they're explaining this is, this was the original, it was solved for A. If you want to inversely express it, that's the hard way of saying, solve it for R. And that's what this one did. It solved it for R. So with word problems, don't switch anything, just solve for the variable that's not solved for. That's what we do. Alrighty, so problem 5. Looks like an interesting problem. Looks like it was warm wherever they were. Finding the inverse of a formula. The function d equals 4.9 t squared represents the distance d in meters that an object falls in t seconds due to Earth's gravity. Find the inverse of this function. How long in seconds does it take the cliff diver who got a day pass from a mental institution and is diving off cliffs reach the water below? Who dives off a cliff? Who looks at that and says, wouldn't this be fun to do? It's dangerous. I suppose all of you are like, I'd be a cliff diver, right? All of you dive off a cliff? Yeah, no, no, 24 meters? Come on. You know, meters are longer than feet. I want you to look at the tiles. These are feet. Just think about 24 of them. 1, 2, 3, and that's just 24 feet. Meters are about 3 of those. Gosh, look at those lovely rocks down there with that water. I think I'll jump in. Not me. Oh, I see. Have somebody jump before you. Yes, yes, yes. You give it a try. Yeah, and then jump in. All right, so what we have to do here is realize that they want us to talk about how long that it's going to take them to hit the water. Well, that's t. This formula is not solved for t. It'll take us longer if we just use substitution, so we want to build this formula to where it says t equals blah, blah, blah. So let's see. Well, this has got to go. Can't have that over there. And that's multiplying by 4.9, so I'll have to divide by 4.9. Can't have that squared there. How do we get rid of squared? Square root. Can time be negative? So we don't have to worry about the plus or minus. Now, if we're worried that there's a radical in the denominator, don't be at this point. Remember, we're just going to use a calculator to find this. We just needed to have a nice formula so we could do this. So here's the real question. If the distance from that top of that cliff to the bottom is 24 meters, how long would I have to scream on the way down? Would it be one unbroken wail, or would I have to stop and take a breath? Let's figure this out. So 24 meters, and it says the formula was built for the distance in meters, so nothing weird about the labels. Square root of 24 divided by 4.9 is t. Well, let's see. Move it down so that I'll know exactly what I'm punching in here. So we need the second square root of 24 divided by 4.9. Pop it out. 2.2, let's go 2.21 seconds. I think one long whale will do it. I don't think it'd do that, but definitely upon the realization that I'm falling through air there, that would be, I could do one. I could do one. It'd work out. Yeah. So 2.21 seconds. Craziness. Down here. The function d equals v squared over 19.6 relates the distance d in meters that an object has fallen due to its velocity v in meters per second. Find the inverse of this function, and then we're going to talk about the cliff diver again. What is the velocity of the cliff diver in meters per second as he enters the water? So how fast was the diver going? That is definitely not solved for v for velocity. How do we get it there? Yeah, they're dividing by 19.6, so let's multiply both sides by 19.6. Then what? Square root? So here comes my question. Can you have a negative velocity? Your science teachers will say, yes, you can. Negative is going down. So plus or minus on this one. Like so. Now, we know the distance for the cliff diver. It was 24 meters, unless they changed it. They did not. Said just keep it with the stuff that you have already. So let's just see. The velocity is second square root 19.6 times 24. 21.69 meters per second. Was he going down? Negative 21.69 meters per second. That, I know you look at that. I'm thinking to myself, I'd want to know what that is in miles per hour. You know, this is very European here with the meters per second, but pretty fast probably. You know, when you're falling, you're falling. So with word problems, we don't switch the x and the y. We don't trade the variables. We just solve for whatever variable is not solved for. Now, we need to talk a little bit more about this whole inverse business. You know that for any function f, each value in the domain corresponds to exactly one y value in the range. That's what a function is. And I know they didn't underline this, but this is the big deal right there. For every input, there's exactly one output. For a one-to-one function, those are really special. Those are the ones where you take a function and you find its inverse and it is also a function. Those are called one-to-one. So that works both ways. For every input, there's exactly one output, and for every output, there's exactly one input. Works backwards and forwards. You can do a lot of calculus with those kinds of things. So it is also true that each y value in the range corresponds to exactly one x value in the domain. A one-to-one function has an inverse that will also be a function. So if f maps a to b, then the inverse must map b back to a. It moves it forwards, and then it moves it backwards. That's what inverses are supposed to do. Undo what you just did. So we've got a key concept here in this box, and that's called composition of inverse functions. If f and f inverse are in fact inverse functions, then something really cool happens. When we compose those functions, when we put one function inside the other, they simplify almost totally away. The only thing that's left is x. And it doesn't matter which direction you do it in. It has to work in both. So the inverse of f of x and f of f inverse of x will both simplify right down to x. Or you made a mistake. So for any x in those domains of f and f inverse, respectively. In the underlined piece, it says, this says that the composition of a function and its inverse is essentially the identity function. And it gives us this little idx, which means the identity function of x. The identity function for x is just the line y equals x. It's like the parent function. So, interesting. This says we're going to compose some inverse functions. So for f of x equals 1 over x minus 1, what is each of the following? Well, before I can figure out that, I have to figure out the domain. This has division. There's something we can't use here. So we need to look at the domain of f. There's one number that would be super bad in this. What's the one number? Yeah, because 1 minus 1 would be 0, and that would have us dividing by 0. So x can't be 1. You can put whatever else you want in f, but you can't put in 1. All right, A says, let's figure out what that inverse is. Well, let's see. There were 2 steps to that when we had x's and y's. The first one was switch the x and the y. There's no y. Yesterday we learned what we could do with that. There is a y there, isn't there? What is it? It is the f of x. So just write it as y equals 1 over x minus 1. Then switch the x and the y. Now, that has a big no-no. We're supposed to solve for y, and you're never supposed to have what you're solving for in the denominator. So we have multiple things we could try to do for this. But most people will tell you, hey, that almost looks like I could cross multiply. But if I'm going to cross multiply, I need this to be a fraction too, because then it'll be called a proportion. So I think I'm going to throw a little 1 down there so I can just cross multiply this little baby. So this will say x times the quantity y minus 1 equals 1 times 1, which is 1. Now I'm still trying to get y all by itself. So at this point, I have to decide, do I want to distribute the x? Because some of you have probably already done that. I see your heads are down and you're doing that right now. Or do I want to divide x from both sides so I can just move it over? Well, either way will work if you do it right. So, did you already start? Did you distribute? No. Okay, so let's divide both sides by x. It's a little faster, a little easier. And then we'd add 1. And you could put either 1 over x plus 1 or 1 plus 1 over x. It doesn't make any difference. What makes a difference here is we just found a restriction in our domain when we did that. We have a number that it cannot be for our inverse. What is it? 0, because we'd be dividing by 0. And now I do want to call it its fancy name because they asked us to find fancy name. So instead of y, we'll put f inverse of x equals 1 over x plus 1. All right, so we have a couple of numbers we can't use. With the original, we can't use a 1. With our inverse, we can't use a 0. Oh, look at B. They want us to do some composition with this. So I have to remember, boy, was it beginning of last week we did composition? About middle of the week when we did composition. I have to remember that this is the same thing as this. And we always put the number into the function that's closest to it first. So it's going to go into the inverse first. Well, let's see if we can do that. Can we put a 1 into our inverse? That was in the black over there. 1's okay, right, for our inverse? All right, so let's put a 1 in there. So we need 1 over 1 plus 1. Well, 1 divided by 1 is 1, and 1 plus 1 is 2. But we remember we're not done, right? We just did the innermost parentheses. Now we have to take that 2 and we have to put it into f. Is it okay to put a 2 into f? Yeah, it was just 1 that was bad. So let's put our 2 back up here into f. Ugh, piece of fluff in my nose. That's another problem with maths here. 2 minus 1 is 1. 1 divided by 1? Hey, it's 1. So there's our final answer. So we're doing composition, but we're doing it kind of the old-fashioned way, where we just say, let's put it into the first one, and then let's put it into the second one. All right, let's rewrite this one. So f inverse of f of 1. So where are we putting the 1? In f. Oh, wait a second. Can we put a 1 into f? No, we said you can't do that because then you'll be dividing by 0. So what do we put there if we can't do it? Same fancy word we've used for slope when you can't do it, undefined. Undefined. So it's a good thing we did that domain first, so we would know, hey, don't have to bother with this one, we can't do it. Now you'd probably catch it anyway, because you'd be taking this 1 and you'd put it up in here and you'd say 1 minus 1 is 0. Wait a second, I can't divide by 0. You'd catch it anyway. But if you have that domain, well, then you can think about it in advance. Alrighty, so here's the got it. Let g of x equal 4 over x plus 2. All right, I'm going to go ahead and rewrite this because I want us to be thinking about the domain. So take a look. What number would be bad? -2. It's out. X can't be -2. Well, A says, let's go ahead and find the inverse. So we remember that g of x is just the output, the y. And then we start finding our inverse. So step 1 with inverses. Swap the x and the y. Phones go down, no packets out. Paying attention. We're here to learn. Switch the x and the y. Then, yeah, it's easiest to cross multiply here. Definitely. So x times the quantity y plus 2 equals 4. That kind of looks like a g. I better fix that. Then what do we want to do? Easiest way to move it over, divide by it right now. Almost. Before I forget, let's change its name. Its fancy name is g inverse of x. John, do you need a packet? Okay, please get it out. Well, we better talk about domain because there's division going on in that, isn't there? What number's out? 0. Alrighty, so our original, we can't put in a -2. And our inverse, we can't put in a 0. So let's see what they want us to do with this. It says for B, come on, Blue. Start up, Blue. Behave. We have g of g inverse of 0. So where are we supposed to put the 0 first? G inverse. Can we put a 0 in G inverse? Undefined. Can't do it. C is backwards. G inverse of G of 0. So can we put a 0 into G? We can and we should. All the way back here. So 4 over 0 plus 2. So that'll be 4 divided by 2. So that'll give us a 2. But we're not done. Because it said do this first. And once you get the answer, now put it in here. Can we put a 2 into G? 2's okay, right? Just not -2. Or wait a minute, G inverse. I'm looking way back here at the blue. For goodness sakes, you're home. 0 into G. Can we put a 2 into G inverse? Yeah, just not 0. We don't have a 0. We have a 2. 4 divided by 2 minus 2. Well, 4 divided by 2 is 2. 2 minus 2, why, that's 0. So we did composition. G of G inverse, G of inverse of G. Back and forth. We have to watch the domains. That's going to be the key. Can I actually put this number in? That's a big deal. So now, let's just talk about things that might have a stranger looking inverse than we're used to. So for problem 7, it says for each function, find the inverse, also the domain and the range, and determine whether the inverse is a function. So here's the original, and right now I want to start with domain and range. Alrighty, let's think about this. So for domain, there's only 2 things that make us restrict the domain. One is division. Does that have any division in it? The other is even roots. Does it have any even roots in it? No, it's got squared power. So this is going to be all reals for the domain. But to talk about the range, we need to think of what this looks like when we graph it. So parent function would be y equals x squared. Everybody draw me what y equals x squared looks like in front of yourself right there. A big parabola, right? This one says plus 3. So what's that going to do to it? Move it up 3. So the lowest y it will ever reach is 3. Y will be greater than or equal to 3. Now, if you're saying, Cedarholm, you lost me at y equals x squared. Well, we have this fabulous invention called a graphing calculator. And you could go into y equals, and you could put x squared plus 3, zoom 6, ta-da! Lowest y value is 3, everything above it. So if you're worried that you don't have all the shapes and stuff memorized, don't be. That's what this is for, to help you out with those little things. Now, we're supposed to figure out the inverse of this bugger. So we better put the y where it's supposed to go to start with. Where's the y supposed to go? On the left. Now let's write the inverse. Step 1. Swap them out. Switch the x and the y. Step 2. Yeah, it's solve for y, but we'd start by subtracting 3, right? Then square root of both sides, and whenever we physically write down that square root, we have to remember to do what? Yes, plus or minus. Well, that's not going to be a function, but let's come back to that because that's like one of their last questions there. So for each function, find the inverse and the domain and range of the function. Did that. And its inverse. Oh, well, that's going to be really easy. Domain of, let's call it f inverse. Come on, Blue, wake up. Do you remember from yesterday why this is so easy? You do. You just swap these. So the range of this one was y is greater than or equal to 3. This will be x is greater than or equal to 3. The domain of this one was all reals. The range of this one will be all reals. No thinking. I love that. You just swap them. So if you did the first one right, all you do is switch them out. Now determine whether the inverse is a function. What did we say about that? No go. It's got the plus or minus. Not a function. Now if you wanted to see what that one looks like, you can't punch this in as just one function. That's because our graphing calculators, they have a plus or minus key in there, but it's not for what we would normally think plus or minus is for. So if we wanted to see that graph, we'd go into y equals and punch in the square root of negative, oops, I'll do that in the next one, x minus 3, and then negative second square root of x minus 3. So that's kind of nice that this has the color one so we can see, you know, which one was which as we go through there. The positive is the one that's up on the top, and the negative is the one that's down on the bottom. So we get the whole inverse because we used plus and minus on that. All right. The square root one, huh? For each function, find the inverse and the domain and range of the function and its inverse, and determine whether the inverse is a function. Oh, this one's going to be a little harder for domain and range. So for this one, let's just set it up with what we know. We know that the stuff under the square root, called the radicand, has to be greater than or equal to 0. Otherwise, we'd be taking the square root of negatives, and that's imaginary. Okay, to solve that, let's subtract 5 from both sides. But I'm not done this time. With all the other ones we did, we were done here. What's wrong with that? It's got a negative. So we're going to have to divide both sides with by -1, which, if our memories are failing us, we will miss one really important step. We just divided an inequality by a negative. What do we have to do? You have to switch the sign. Yeah. So that's one of the reasons that I added this one on here, so that we could remember inequalities are strange because if you multiply or divide both sides by a negative, you have to flip the sign. So our domain. Well, we might want to see this one graphed to figure out the range. So let me put that in. Square root of -x plus 5. Oh, look at that. So it's that curve that I showed you yesterday, but backwards. And it's turned around backwards because of the negative that's in front. But now what I really want to figure out is, so what y values can I use? Well, there's the lowest y value, and that's at 0. And I see that the blue is above that. So it's going to be y is greater than or equal to 0. So a little more work for domain and range than we've had to do in the past. Now we can start doing the inverse. So let's make our good old f of x a y. Oops, put my negative outside instead of inside. Steps to an inverse. Step 1. Switch the x and the y. Well, that's not very handy. Look at that. We need that y, and it's underneath that square root. We can't get rid of it until we do what? We have to square both sides. Yeah, we have to. We don't have a choice. We can't gain access to that as long as it's in there and attached to that plus 5. Then what would we do? Subtract 5 from both sides. Done yet? One more thing. Divide everything by -1. And then we better give it its fancy name, F inverse. So there's our little inverse. Well, that's interesting. A negative x squared. So that would be a down opening parabola. But then we'd move it up 5, so up there like that. But we don't need to do all of that. Because when we find the domain and range, what's the easiest way to do it? Just flip these two. Yeah. So the domain of the inverse and the range of the inverse. Well, for the domain, we go back to the range. And we just make it an x. X is greater than or equal to 0. For the range, go to your domain, make it a y. Now we've got it. Find the domain and range of the original and its inverse. Determine whether the inverse is a function. Well, let's look at it. Here's our formula. Is that going to be a function? It is. There's no plus or minus in that. So this time, this is a function. So this one, probably the toughest one we did today, because you have to remember all of those little facts that you've known from properties of algebra in the past. And the big one here is when you multiply or divide by a negative, you have to flip that inequality. Well, that is 6-7. We've got a day 2 assignment to work on. And I should check on that and see if you need some graph paper again for that one.